on the temperature control unit. It's control.
On this last part.
Okay. Yes, maybe I say that. This here is oil. It looks like water. Never put water in there. There's some if there should be a hole or something like that, you will call us anyway, I think. But never put water in there. It's written there. Use only silicone oil. M40 165 10. Do not fill in water. Please don't fill in water. It can destroy the machine. Otherwise, you will have to drain all. You will have to drain everything as well. You don't want to do that. Here, it looks like water, so don't fill in water there. What is it? It's oil.
Oil.
Yeah, we have this. The machine works. It has an oil circuit in there for controlling the temperature. So the aim is, as I mentioned yesterday, to control the temperature to 0.1 Kelvin. And there's a water oil heat exchanger down there, and this one is supposed to control the water temperature. So once you start that, it always gets at 20 degrees C. It's programmed in a way that it's always going to 20 degrees C. Once we start the LabVIEW for the temperature control, there's a button in the LabVIEW program. I will show you that later as well. Take control of the machine, and then you can control the temperature from inside the office. Okay. What we already did yesterday is adjusting the scan area. What we should do now already is to load the scan area. I did not do that again today. I may have done that. The same thing is for the geometry of all the parameters. Same is also true for the scanner. For the scanner, you can reload. We will check that. Yeah. Here's the scan, so it's always scan, SCN, SD. But if you're in the scan window, you're not able to access the STP files. If you're in the STP program, you're not able to access the STP files. This computer is no backup. So if this computer breaks and you have not downloaded your files, they will be gone. Right? You can download it from the computer which is down there. So save them somewhere where you have backup or something. So this has no automatic backup. So that was already the area from yesterday. I don't know, the selector might always change. I would just set the ventilation to about 50%. Okay? What we also can do now already is to switch on the data acquisition. I will not do that because at the same time I want to run the scan after we start the test. So we will do the scan during lunchtime because it's automated. We don't have to wait here. Only one line No, that's the air conditioning system. What we will see maybe is that the air conditioning system may have a little influence on the wind, because the air conditioning system is also blowing in that direction and we blow in that direction. What we will see is, or what was the last time was the case, that the temperature here is a bit lower than the temperature over here. We will see that. So what I always do is making the mean temperature of these two and then calculate that on the efficiency. Okay. These are the lamps. Maybe I tell just some words about the lamps.
Yeah, give to you.
I will do some more.
You don't have to watch, just
I will tell you some more things from my
it's almost
experience in the past when we were in the office. So, as I told, these lamps don't generate parallel light as we have outdoors, right? So, if you have a lamp like this, the angles will be like that. So, in the middle of the test area, you will have some light of this lamp, and some light of that lamp, some light of that lamp, some light of that lamp, and some light of that lamp. So, if your collector is like this, what I always do is put these a bit further here and these a bit closer together, because otherwise you will have most of the irradiance in the center. So this is how I regularly do start if I don't know any configuration design. We will do that now. We will not, during the training for the next 1 or 2 days, we will not do that a lot. It's very easy to adjust these things. Take your time, try that out, get a feeling for that. Use the values of your colleagues like Ting, James, Costa, whoever has already tested that. Ask them about their experience. It's also sometimes a bit about reflection in the room. So ask them about their results. They are here, I'm pretty sure. If not, you can upload them again. So once you have downloaded the files, you can also upload them again. Ask them about their configurations. Normally, it's about 1.70 meters to 1.50 meters. It might be a bit easier to get good homogeneity with 1.70 meters distance.
So usually the height is fixed.
What do you mean the height?
The distance
between that's we set that.
You could change
I
it.
know, but before that, whenever we were doing the test, usually this height was fixed. The guy were just playing with the XY position of the lines.
That was his
No,
choice.
you can also
choice.
also adjust the distance by putting 1.60 meters or something. But you should always. It's not only the intensity will rise as closer you are getting, and if you look at the lamp, I have some pictures about that. If you're directly in front of the lamps, the circle of the light, if it hits a position that's small like this, the further you go away, it's getting bigger, and it's getting bigger. So if you're very close, you will just have dots which will not have the chance to fit together. So if you go further away, it might be a bit easier to adjust them in a way to reach a good homogeneity.
So that should be around that number that you just said.
My suggestion is between 1.50 meters and 1.70 meters. The problem will also be if you go way below 1.50 meters, the intensity on the test platform will be very high, so you have to dim the lights a lot.
Yeah.
What is also my suggestion, never start at 100%. Go to 90, so you can go a bit lower and go a bit higher.
what's driving everything is homogeneity. That's your target, and that's what's driving placement of the lamps, distance.
Yeah,
pretty much.
for flat plate
For flat plate.
for flat plate things, I would say yes. As I already tried to explain yesterday, if you have different geometric shapes, like vacuum tubes, it can also make sense to put the lamps a bit closer together, because then the portion of your direct irradiation gets higher. So the standard for collector testing allows a homogeneity of plus minus 15%. So which is
That's a lot.
this is for thermal. For PP it's less.
All right.
But you don't have round PP modules. It's about the incident angle modifier. If you have a lot of irradiation for flat things, which is going, you can have a degree of about 30 degrees and will not have not much or close to none influence. So because you don't have the reflection does not change. But if you talk about reflective coatings, for example, they are also just made to accept a certain irradiation in a certain range. We can have a look. If you look at in a manufacturer from anti-reflective coating, it's mostly round about 30 degrees
From the normal, both sides of the
from the
normal.
normal, where they accept a lot of. Afterwards, it will decrease very much. For vacuum tubes, it's a bit different. I will show that later. But I will show that later. It's way easier with pictures. I have a presentation. I brought a presentation. Okay. We have adjusted the geometry. We adjusted the lamps. We're not going to measure yet. Do you know the thickness or the distance between the back of your collector to the absorber? Maybe it's 2 or 3 centimeters. Okay, so I would say maybe we type in 3 centimeters. That's the thickness of the collector. We already can put that in at the moment. So that's for after the scanning. We have to go in the right position in order that we shift the pyranometer to the collector or the absorber area. So we learned it's about 3 centimeters. Normally, if you test that, rather if you have a collector you develop yourself, you will know that. Normally, it's in the specs somewhere. If you test somebody for a customer, it's mostly somehow in the specs. What's the distance between the glass and the absorber? Okay, we have to switch on the lamps. What we also should do is to switch on the artificial sky just by pressing the on button.
This is kind of filter.
Just turn it on.
And this is how much belongs to the sun.
Yes. Pump is always running on speed. As we learned, I guess the cooling system on that side is running all the time. Maybe it's not that, because I saw that there's a dry contact, which is named chiller. Maybe this is giving a signal to your system that it's not running all the time.
You want to give this some time, right?
No. I'm just talking. It will heat up again because when we switch on the lamps, the configuration will be a different one. And setting the lamps, we have another switch on already. We see that they are off at the moment. For the switching on the lamps, it's the same. We can either one. Or you can set all, whatever you want. We're playing around with the homogeneity. I said not go below 75%. My suggestion is also here to visualize the
camera
output.
one. There's here, it's 25 years later.
This is a guess.
Just as an initial guess.
Half of that is not real.
Yeah. I could have loaded, but I've not found my starting configuration because it was close to that.
Yeah, the interesting to see Costas and James.
Nope, sorry. Nope.
Parameters to see that. We'll probably do that with the same pattern.